boots on the ground. Let's start designing intuitively a SLAM 2D mapping algorithm. So we have our robotic vacuum cleaner at a starting point, which is a known point, it's charging point. It has its origin, and the orientation is 90 degrees. In order to perform any type of SLAM algorithm, we need a set of sensors. So first, let's consider the vacuum cleaner sensors. It has some sort of ranging, which is, in our example, 4 point rangers, front, back, left, and right, and some sort of orientation. A very important ingredient here is a sensor for its velocity. So its velocity, if it's a ground robot, could be gained through some sort of encoding or just counting the number of cycles the wheel has performed. But thinking of a drone, it has an optical flow that in a way encapsulate the number of pixels going through, and by calibrating it with its height, you get some sort of velocity. These days drones, even the toy grade drones, are performing it. Now, you have some inaccuracy in your sensors. So for simplicity, our range sensors can do 0 to 3 meters. Its accuracy would be, let's say, 1%. And our velocity would be, say, 5% average accuracy. So if you go along a corridor of, 10 meters, your expected error would be half a meter, plus minus. Finally, the yaw sensor would be based on a gyro, and you can think that its average error along the Y or average drift would be, say, 1 degree a minute. This is actually could be more than that, but it's there are like round numbers to play with. Now let's start with inventing an intuitive SLAM algorithm. The robot starts, it moves, say, 1 meter, and along that 1 meter, it performs its ranging. Continuously doing it on a fixed pace, and try to maintain, say, the middle way in the corridor between the left and the right walls. Now, whenever there's a case of intersection, meaning either on the left sensor or on the right sensor, I have a considerable or a large or a big enough discontinuity. Now, its left sensor has moved from 0.5 meter to 2.5 meters. We would consider this point to be a case of feature points or an interest point. I would mark it as a potential intersection. I might go along the corridor, but I will remember, the robot will maintain this information as unexplored branch, or I need to take a right here, or I need to go north in terms of global orientation in this intersection. Going backwards, I would need to A, detect the intersection, B, recognize that this is actually the intersection I haven't been explored in the beginning. So we are in the process of intuitively coming up with this notion or a method or an algorithm for an autonomous vacuum cleaner to explore the room, to vacuum the room or the building, while having a good map that will allow it to go back to its charging point, to its start point. This vacuum cleaner, as going along the corridor, it was able to detect a feature point, a point of interest, or an intersection, possible intersection. It continued along the corridor. It remembered that it needs to go back to this interest point or unexplored area and explore it afterwards. And now, along the way, so we have those intersections that we will formally define as nodes. We have between two nodes, say, a path that we will define as an edge. And the entire kind of network of nodes or intersection and edges, you could be thought as kind of a infrastructure of roads or a road network. More formally, we would think of them as a graph. A graph is a data structure in computer science, a very popular data structure in computer science, which composed from intersection and edges. And in our SLAM algorithm, it would be extremely important to detect those nodes, to have some sort of measurements along the edge. And as long as I'm working locally, this is a very important observation. As long as I know that I move from one node to another, maybe it took me 5 meters and maybe it took me 5.5 meters. But just as human can go back home and recognize their, their car or have catch a ball, and we do that perfectly without an accurate measurements of distance. We do that by performing a local kind of comparison and say, okay, I know that from that node I need to walk, say, few meters till the next node, or I need to go through few left turns and avoid them, and just on the fourth left turn to take that turn. In a way, we will try to mimic those notions into our SLAM algorithm for vacuum cleaners, for robotic vacuum cleaners.